So the one thing about section 9.8 that we really need to make sure that we know, because we probably don't know it right now, is it's about bearing. And bearing has to do with a direction on a compass. So on a compass looks like this, where it is north, east, south, and west. And if you didn't know that, that's what it looks like. But bearing is basically saying, or if it tells you that a ship has a bearing of, or something has a bearing of, it is talking about the acute angle formed with the north and south line. So it says something like this. It's an acute angle made with the north and the south line. So like if I give you something that says south 40 degrees east, then basically it's telling you that it wants you to go south first and then 40 degrees towards the east. So as I look at my compass, south is down here. So my angle would be south. I'm going to try to make that a good line. So it'll be south, and then east is this way. So it's telling you to make that angle 40 degrees this way, and this would be a 40-degree angle. That's what it's telling you to do. Okay. So anytime that you see something that looks like this, it is talking about that angle between east and west, but it gives you the direction north or south first, and then it gives you the bearing. So like if I said north 30 degrees west, then on my compass, I know that north is up here. So I know I'm going to use the acute angle this way. And then 30 degrees west would be going this way, and this angle would be 30 degrees. All right. So that's what it's really asking you to look at and asking you to do. Okay. So I want to go through one example. And this one example, it should kind of tie in all of the other questions that you would end up running into in this chapter. But it's a pretty straightforward concept. It just requires a lot of different things that you need to kind of work through. So this is specifically a bearing problem. And with that bearing problem, there's just a lot of different steps that you need to do. Okay, so I'm going to type this one in so you don't have to read my handwriting. It does come from your book, so I am using a book problem right now. But I'm going to type it in just so that we don't have to read my nasty handwriting. Oop. All right, so here's the question. And with this question, what we're going to do, or what the book actually gives you a picture along with it. But I want to make sure that we understand kind of what's going on. So first thing that it's going to ask us to do is find the ship's bearing. And the second thing it's going to ask us to do is find the ship's distance from the port of departure. Now, the picture that it gives us looks something like this. Oh, that's a good picture. But anyway, it gives you something like this. You kind of get the idea. All right. And then it also tells you what kind of what's going on in the question. So the ship is starting right here. And then it tells you that the ship leaves the port and heads due west at 20 knots, or 20 miles per hour, or 20 nautical miles per hour. So it tells you it's heading this way at 20 miles an hour, or 20 nautical miles an hour. At 2 p.m., the ship changes course. So right here, the ship is changing its course. And what we really need to pay attention to at that moment, the ship is changing its course. So that means that after 2 hours, the ship changes its course. So it has traveled 2 times that 20 miles per hour. So it has really traveled 40 nautical miles. So at this point, the ship starts here. It's traveling due west. It's traveled for 2 hours. In those 2 hours that it's traveled, it has traveled 20 miles per hour. So it is 40 miles away from where it started, or 20 nautical miles. The next thing that it tells you is the ship changes course at this point right here. And then it specifically says that it changes course at north 54 west. Okay, so north 54 west. So north, this is my north line because it's straight up and down. So north and then 54 degrees west. So it's telling me right here that this angle is 54 degrees. So it tells you right there that that angle is 54. All right. So since I've got that part of the angle, what I'm going to do is I am going to, I guess I have a little more information that I can fill in. Right here, I know that the ship I want to find the ship's distance from the port of departure at 3 p.m. This was at 2 p.m. at this moment. This is at 3 p.m. So they've traveled 1 hour this way, which means that this distance is going to be 20. And now I can kind of come up with a bunch of different things, right? I can come up with a bunch of different ideas. So a few different things that I can come up with, or a few different things that I can think about, is I can come up with a bunch of different, I guess, measurements, right? So I can come up with a bunch of different measurements as I travel or as I look through things. Right now, I know that this angle is 90 degrees. I'm going to change this to red. So this is all the stuff in black is stuff that I know on my picture right now. Everything in red is stuff that I'm going to be figuring out. So right now I know that this is 90 degrees. I know that this is 54 degrees, which means that I should be able to figure out what this angle is, right? These two angles should add up to 90 degrees, which means that this is going to be a 36-degree angle. So the two things that I'm really being asked about is I'm being asked about the ship's bearing. I'll put this in blue, what I'm being asked about. I'm being asked about the ship's bearing, which basically means how big is this angle? So I want to know how big that angle is at that moment. If I can find how big that angle is, that tells me what the bearing is, right? Because I can just basically draw my north-south line right here, and then it tells me what the bearing is, okay? So that will give me the bearing. And then what I need to do is I need to figure out the distance from these 2 points together. So I need to figure out those two distances. So right here, I know that I have an angle and I have a side. And basically, I just have to try and figure out the rest of this triangle, right? So I have to figure out the rest of this triangle. And if I can figure out the rest of this triangle, then I can really come up with this distance here. So if I can figure out this part and I can figure out the triangle, I can figure out lots of stuff, right? So what I'm going to do is I'm going to pay attention to this triangle on the left side right here. And I want to find this distance. So I'm going to say that I have the sine of 36 is equal to x over 20, because that will give me this distance right here. So now I'm going to do the sine of 36. And remember, this is in degrees, so your calculator should be in degrees with this. So I'm going to use degree. So sine of 36, which is 0.5878. And I'm going to multiply that by 20. And that will give me that distance of about 11.8. So this tells me that this is 11.8. So this height right here is 11.8. And then the other thing that I can do is I can figure out how big this side length is down here using the same kind of idea, or I could use Pythagorean theorem. It doesn't really matter. There's a lot of different ways that you can figure out this length down here. But if I figure out this length down here, then I have really figured out this whole side length. I figured out this whole side length, and then I can use the Pythagorean theorem to figure out that whole side. So I'm going to do using only this triangle, and we'll call this like D. So I'm going to do D squared plus 11.8 squared equals 20 squared. And then, so I'm going to go through and solve that part. So I'm going to get 400 minus 11.8 squared. So I'm going to get D squared equals 260.8-ish. And I'm going to take the square root of that number, and I'm going to get about 16. So this answer right here is 16. Actually 16.1, we'll call it. And now if you've noticed, we've really found out these two length, this length down here and this length right here. So I found out a lot about this triangle, right? So now basically what I'm doing is I'm coming up with a whole bunch of different ideas and different answers as to you know, this big triangle. So I've come up with this big triangle now. If this is a picture of the big triangle, I know that this is 11.8, and I know that this one down here is 56.1, and this one right here I don't know, but this will be the answer to one of those original questions. The initial distance, that will be the answer to that initial distance right there, right? And so that allows me to figure out exactly what I'm looking for, and that allows me to figure out exactly what my distance is going to be. So if I know what my distance is going to be, I'm going to do 11 squared plus, or 11.8 squared plus 56.1 squared. And then I'm going to take the square root of that answer, and I get about 57.3. So my answer will be 57.3 nautical miles from point to point. So this will give me 57.3. And then finally, the last thing that asks me to do is find that angle down there. And there's several different ways I can find that angle. I can do sine of x is equal to 11.8 over 57.3. And then now I can just do the inverse of that, right? So I can take the inverse of sine. So inverse sine of 11.8 over 57.3. And I end up with 11.9 degrees. So I end up with 11.9 degrees on that, right? Now, that being said, that is not the bearing, right? Because right now, if I'm asked the bearing of this, if I look at the bearing, so if I said north 11.9 degrees west, what that picture looks like is on my compass, I have north, and then 11.9 degrees would look like this. That's not what I want. I want my picture to open up. So basically, if I look at this, I'm coming up with this being north right here. I want to know what this angle was right here, right? Because if that's my bearing, this would be my north line. This would be my bearing line. So I know that this is 11.8 or 11.9 degrees. So this thing right in here is 11.9, which means that this one right here is going to be 78.1. So my actual bearings are going to be north 78.1 west. So that's the bearing that the ship took from the original port. And then the distance traveled is 57.3 nautical miles. So really the only thing that was new, this was just like a problem that you would have seen in geometry where it's just a big set of puzzle pieces, right? A lot of stuff is going on, a lot of stuff is happening, lots of weird combinations. There probably is not one method that works to solve this. You could use whatever you wanted to, however many different methods you could see, you could use whatever you wanted to look at, and then you could come up with a method. That being said, my method is not the only method. You could use one of probably 50 different things to come up with the exact same set of answers. It's just a big puzzle. The only thing that's really new or that we haven't talked about is the ship's bearing. And I hope that that's not something that's too complicated to be able to understand. Do you guys have any questions as you sit here right now and look at this? All right. So that's really the only thing I wanted to do. The rest of this is all just practice. So tonight, what I want you guys to do is at least look and try a couple of these problems. Tomorrow, we're going to review for our Chapter 9 test, and then Friday, we'll take our Chapter 9 test. So tomorrow, we'll have time to go through any questions that you guys have or anything that you guys want to look at, and then we'll get ourselves ready for Friday's test. Okay?